This is one of the most important physics concepts, and it's almost a guarantee to come up on your MCAT. Pictured here is an atom with an electron right here, and the electron is occupying this first energy level. The second circle is the second energy level, and the third circle is the third energy level. The first energy level is the lowest energy, and then there's an energy difference between that and the second energy level. If this electron gains exactly the same amount of energy that separates energy level 1 from energy level 2, then it's going to jump from energy level 1 up to energy level 2. Or if it gained the exact amount of energy that separates energy level 1 from energy level 3, then the electron would jump up to energy level 3. And the way that the electron can gain energy like that is by absorbing a photon, which remember is a particle of light. The photon that it absorbs has to have the exact amount of energy that separates energy level 1 from energy level 2, or energy level 1 from energy level 3. If it has an energy that's between those energy levels, then that electron will not be able to make that jump. It has to be that exact same energy. Let's say, for example, that we shine some blue light onto this electron, and it causes the electron to go from energy level 1 up to energy level 2. We then know that the photon contains the exact same amount of energy that separates energy level 1 from energy level 2, and we can use the wavelength of that photon to calculate that energy. This equation here takes the speed of light and says it's equal to the wavelength of that light times the frequency. The speed of light is 3 times 10 to the 8 meters per second, and the wavelength for blue light is around 450 nanometers, which is 450 times 10 to the negative 9 meters. You want to then solve for the frequency, so the frequency is going to be equal to 3 times 10 to the 8 divided by 450 times 10 to the negative 9. I'm going to change those numbers to be 3 times 10 to the 8 divided by 4.5 times 10 to the negative 7. That then comes out to be 0.66 times 10 to the 15, and our unit for that is hertz. Now we can plug that frequency into E equals hf. E is the energy of that photon, h is Planck's constant, which is 6.6 times 10 to the negative 34. So to find that energy, we do 6.6 times 10 to the negative 34 times 0.66 times 10 to the 15. I'm going to round this to 7 and say this is 0.7, so we have 7 times 0.7. That comes out to be 4.9, and then we need to add the negative 34 to that 15. So we have 4.9 times 10 to the negative 19th, and that unit is joules. So this represents the amount of energy that was in that blue light photon, and that's also equal to the energy difference between energy level 1 and energy level 2, because the photon, when it absorbed that blue light, jumped from energy level 1 up to energy level 2.